Hello and welcome to my channel. My channel focuses on engineering, especially for all of you guys who are studying engineering at university. I randomly select different subjects and different modules, and I will take you through different problems and show you the best way of dealing with different problems and solutions. The best way that I have found when I have completed my honors in engineering. In today's lesson, I'm going to show you interval notation, which is one of the foundations or basics within the calculus or applied maths. Take you through a few examples of interval notation as well as how you use them in inequalities. So basically, what is interval notation? So interval notation is a way of writing subsets of on the real number line. When I was studying engineering, I broke this down into three main types. So let's get into the different types, and I'll take you through how these types can help you understand interval notation better. So we have type 1, and type 1 is basically called the open notation. And this is simply written as a round bracket A and a round bracket B. Now you can see that both points A and B are rounded. I have round brackets or round parentheses. So if you want to draw this on the number line, we will draw it as A and B. And due to it being round brackets, it means that points A and B are not included. So we'll draw a round circle and not a solid circle on A, and also not a solid circle on B. And we go A to B, left to right. Quite simple, right? So let's get into the next type, which is type 2. So type 2, as you may have guessed it, is the opposite of open, which is closed. And the way we represent closed is with square brackets. So A comma B, square brackets. So if we are to write this on the number line, we will show points A, point B. And now because we have our square brackets, we are going to include A and B. So you have two solid circles at point A and at point B. So quite simple, right? Round brackets for open and square brackets for closed. Let's move into the third type, and this one is a combination of the two. So we call type 3, and we call it half open. And we will show this as, one way to show this as, let's say square brackets, let's use X this time, and point Y, and round brackets at point Y. So if we were to show this on the number line, how do you think we would do that? So we would have the number line with point X, point Y, and we now need to show both points, and we would have a solid circle at X and an open circle at Y, and we join the two. Solid circle at X, because if we scroll back up, we can see that it was a square bracket, and open at Y, so a round bracket. Type 3 can also be written in at the opposite way, so we can show this again as X and Y, but this time a round bracket at X and a square bracket at Y. So basically, if we show this on the number line, X and Y, we would then show that this time X is a circle, open circle, and Y is your closed circle, and we move X to Y. So that's basically the three different types that we have for the interval notation. Quite simple, quite easy to understand. I'm going to move on to the next part of this, which I want to show you infinite intervals. So if we want to look at infinite intervals, and as the name suggests, we want to look at numbers on the number line going to negative or positive infinity. So in infinite intervals, you just have two types. So we have our open type, and open is basically represented as, let's say, x open bracket and infinity round brackets. So both round brackets. Showing this on the number line, we will have x and infinity, and we would then have a open circle at x going all the way to infinity. The other type, as you may have guessed again, we now have our closed interval. So we got closed, and this time we have our square bracket x and infinity round bracket. And if we were to draw this on the number line, we would draw this as x going to infinity, but this time around we would show x as a solid circle and moving all the way to infinity. Now just take note of the pattern here for infinite intervals and ask yourself a simple question: what is the pattern that you can see here? I will show you the pattern later on or in the next few examples. So let's get into some of the examples. Let's start with a simple example of inequalities. So let's look at x that is greater than 3. Okay, if we were to show this on the number line, we would show this as negative infinity going up to positive infinity. We're going to show 0 here, and we're going to show 3. Now if you can see the inequality itself, it says x is greater than 3, meaning that x is going to be a round circle, so we're not including 3 for x, and we're moving all the way to infinity. So if we were to write this in interval notation, we know that because 3 is not included, we're going to have a round bracket, then we're going to have 3 comma infinity round bracket. Always remember, when you are writing these notation, we always start with the smallest number first, and we put that smallest number on the left, and then we put the largest number on the right. Quite a simple example. Let's move on to another example. So let's look at x that is greater than or equal to 4. Once again, let's look at drawing up the number line, and we have negative infinity to infinity. Let's plot 0 as well as 4. Now this time, as you can see, we are saying that x is greater than or equal to 4, meaning that we would include 4 in here, and we'll go all the way to infinity. So if we are to write this out, we would have square bracket 4 all the way to infinity round bracket. Okay, so let's look at the simple rules. So I took you through the 3 types of interval notation, but let's look at the rules, especially when it comes through to inequalities. So few things to remember, right? If we have less than or greater than, we always gonna say that this is open, so we'll always use round brackets. If we have less than or equal to or greater than or equal to, we always gonna say that this is closed, and we'll have square brackets. Now let's look at the third one, which was the question I asked earlier on for the infinite intervals, and I asked you to look at the pattern. So for infinite intervals, we will always have and always show either negative or positive infinity, and this will always be represented with round brackets. No exception here, always round brackets. So quite easy to remember, 3 types or 3 rules. So let's continue with a few more examples now that we know this. So let's look at an example with x that is less than 1. So if we are to draw this, we draw it on the number line, and we have negative infinity going to infinity. We're gonna have our 1 here. So this one as well, quite simple. X is less than 1, so we're not including x, we're not including 1, and we're moving all the way to negative infinity. So in order to write this out, we go from smallest number to the biggest number, so negative infinity to 1 round bracket. So round bracket for infinity as per the rule, and round bracket for 1 as it's not included. Okay, let's look at a few more examples. Let's look at x that is less than or equal to minus 3. So let's use the number line again, and let's show negative infinity, positive infinity. We can have minus 3 here. So we can see that we need to include minus 3 because of the equal to sign. We will then include minus 3 and move all the way to infinity. So in order to show this, we would represent it as smallest number first, so negative infinity to minus 3. However, we will show this with a square bracket, we including minus 3. Let's look at a more interesting example. Let's look at minus 3, x, and 5. So in order to read this, right, we start with x, right? So x is greater than or equal to minus 3, and x is less than 5, right? So simple reading of the interval. So if we put this or place this on the number line, we would show minus 3 and we would show 5. Now we know that x needs to be greater than or equal to minus 3, and it needs to be less than 5. So we're going to include 3, but we're not including 5. So basically what we would have is inclusion of 3, not 5, and we want to get all the values in between here. So in order to represent this, it will be a square bracket minus 3, 5, round bracket. Very important, understand how to read the equation up here. We start with x, so x is always, well, in this case x is greater than greater than or equal to minus 3, and x is less than 5. Let's move on to another example. Let's use the example of x is less than 0 or x is greater than or equal to 3. This one is quite interesting, right? So if we draw this on the number line, we would have our negative infinity, infinity, we would have 0, and we would have 3. Now looking at this, let's break this up first, right? So we can visualize it. X needs to be less than or equal to 0, meaning that we will have a round bracket at 0 and moving all the way to negative infinity. X is now greater than or equal to 3, so we'll have a closed circle here, or in this case a square bracket, and we move all the way to positive infinity. So if we were to write this out, we would write this as negative infinity to 0 and smallest again, so this will be your square bracket. We will have 3 to infinity. But we're not done yet, right? Because we are checking for x that is less than or equal to 0 or x that is greater than or equal to 3. We know that no points here can intersect. We can see it right here. So we'll say union. Upside down U greatly associates itself with the word or. So when you see or, you are most likely going to use union, and you'll have 2 points or 2 subsets. So let's do one that is the opposite. So let's say we have x that is greater than 1, and, very important, and x is less than or equal to 6. So how do you think we need to represent this? So let's visualize it first. So in order to visualize it, we need to draw two number lines, right? We want the end, so basically we want the points between those. So we would draw negative infinity to infinity. We'll draw 1 here, and we know from here we're saying that it needs to be x needs to be greater than 1. So open circle, moving to the positive direction to positive infinity. Then we have x that is less than or equal to 6. So in order to draw this, let's draw another number line like I said, negative infinity to infinity. We're gonna draw 6, and we know that 6 is included, so we're gonna have that as a solid circle moving to negative infinity. So how do we write this? The way we would look at this is that we would need to be able to find the points between 1 and 6. So we cannot go further than 1 on the left. Let me just show you that. And we cannot go more than 6 on the right. So in order to show this, we know that 1 is not included. We would write this as 1, 6, square brackets, meaning we would only get the subsets or the information or the numbers that are in between 1 and 6. Okay, let's move on to another example. So let's look at something getting a bit more complicated. Let's look at the inequality of 2x minus 1 is less than x plus 3. So let's do the first thing of bringing all the like terms together. So we have 2x minus x is less than 3 plus 1, which means that x is less than 4. So if we were to draw this, we would have negative infinity to infinity. We would have 4. However, 4 is not included, so it's a round circle moving all the way to negative infinity. So we would then write this as round bracket, smallest first, negative infinity to 4 round bracket. Okay. Let's look at another example. Let's go slightly more complicated. This is where your maths comes into play. So let's use minus x over 3 is less than 2x plus 1. So the first thing we need to do is, as you may guess, let's get rid of the denominator 3. To do that, we multiply both sides by 3. So we'll have 3 into minus x over 3 is less than 3 into 2x plus 1. So 3 and 3 cancel, so we have minus x is less than 6x plus 3. Okay, so remember we're solving for x, so let's take the like terms to the same side. So we have minus x minus 6x is less than 3, and this is basically minus 7x is less than 3. We need to solve for x. So first step, let's divide by 7 on both sides. So we have minus x is less than 3 over 7. We need x alone, so we need to divide both sides by negative 1. So we have x is greater than minus 3 by 7. Now, take note, whenever you divide by a negative, you need to change the sign. I will cover this in another video, but just remember for now, anytime you divide by or multiply by a negative, you need to change the inequality sign to ensure that your solution or x is still relevant to your question and still relevant to the number line. Let's do two more examples. Let's do 6 over x minus 1 is greater than or equal to 5, where 6 over x minus 1 must be greater than 0. So from this, we know that x has to be greater than 1. We cannot have x at 0. Okay? Because we will end up with minus 6. Okay? So let's see how we solve for this. So firstly, we get rid of the denominator. So we're going to multiply both sides by x minus 1 into 6 divided by x minus 1 is greater than equal to 5 into x minus 1. That and that cancels, so you have 6 is greater than or equal to 5x minus 5. So let's take all the like terms to one end. So you'll have minus 5x is greater than or equal to minus 6 minus 5. So minus 5x is greater than or equal to minus 11. So let's get rid of the 5 first. So if we divide both sides by 5, we have minus x is greater than or equal to minus 11 divided by 5. Once again, we're solving for x and not negative x. So we know we need to divide both sides by negative or minus 1. So we have x is now less than or equal to positive 11 divided by 5. Once again, the application of dividing by negative changes your inequality sign. So how would we write this out, right? So basically, we know that we were given that 6 over x minus 1 must be greater than 0, which means that x cannot be has to be greater than 1, cannot be anything equal to 1 or less than 1. So that's our smallest value. So we have round bracket 1. Our biggest value here is x needs to be less than or equal to 11 over 5. So that will be our biggest value we can have. And this would be a square bracket because we are saying equal to. Okay. So let's move into our final example. Let's do something a bit more tricky. Let's use a quadratic inequality. So let's say we have 6x squared minus 5x is less than or equal to minus 1. So in order for us to solve this, we need to take the 1 across. So we have 6x squared minus 5x plus 1 is less than or equal to 0. Let's factorize this equation. So we would have this as we need to get to the positive 1. In order to do that, we factorize minus 1, and we will have also minus 1. We need to get to the 5x and also to 6. So we'll have 2x and 3x, right? So this is simple quadratic, solving a simple quadratic equation. Probably done this in senior high school. So in order for us to now find out what are the points, we would know that 2x minus 1 needs to be less than or equal to 0. Okay, so this means that x is less than or equal to a half. Okay, simple. We took the 1 across, we looked at it. So this is one point that we have. Okay, let's look at the next point. So the next point we would have is 3x from the factors that we had is greater than or equal to 0. So this means that x is greater than or equal to 1 by 3. Or we would have 2x minus 1 is greater than or equal to 0, meaning that x is now greater than or equal to a half. And we would have the 3x minus 1 is less than or equal to 0, which means that x is now less than or equal to 1/3. Okay, so we have basically 4 points. So if we were to plot the 4 points on the number line, it will look something like this. So let's use where 1/3 is greater than or equal to is greater than or equal to 0. So we have x is greater than or equal to 1/3. So we'll have 1/3 plotted here, and we move all the way to infinity. Then we have x is less than or equal to half, so half would sit around here, and we know it is saying it's less than or equal to half, meaning that we'll include half and we'll move all the way in that direction. Then we have the other 2 points, which if we plot it on the number line, it will look like where we have 1/3, which is less than or equal to x is less than 1/3. So solid line or solid circle moving to the left, and then we would have half that is greater than x is half, x is greater than or equal to a half. So let's just plot this. So we include a half and we move all the way to the right. So we have four number lines, right? However, we need to find whatever where we have 1/3 and a half. So we find the intersection of the two, meaning that we can only go down here. That's the furthest, and we can only go up there. That's the furthest we can go. So we want, including 1/3 and a half, we want everything that's in here, and that will solve our inequality. So if we were to write this, we would write this as we need to include 1/3 and a half, and that's our round brackets, our square brackets, sorry. And yeah, that is basically it for interval notation, as well as our inequalities and representing those with your interval notation. So just a recap, take note of the 3 types. So we got the open, the closed type, as well as the half open type. Also take note of the other rules. So if you have less than or greater than, you'll always be using a round bracket, meaning that it's open. If you have less than or equal to or greater than or equal to, you'll always use square brackets, meaning that it is closed. And then the special case is positive or negative infinity, where this will show always as a round bracket. So thanks for joining me on for this video. Look out for more videos, as I will continuously post new and exciting videos about each and every module in engineering that can help you pass your engineering courses, as well as ensure that you become the best engineer and you are able to tackle all of your exams as well as your tests. So thank you, and see you next time.